Okay, so this example 4 and 5, these are honors topics, so if you're not in honors, you don't have to do these example problems unless you just want to. But this, you guys, is a faster way to expand polynomials, especially when we get 3 or higher. Okay, usually if you have something to the second power or third power, it's not that hard to expand like our previous one we did with an x to the third, or sorry, something to the third, and it wasn't too bad. I mean, it did take a lot of steps. Okay, but Pascal's triangle is a way where we don't have to do as much work and we can get the same answer. So it's kind of like a shortcut. We don't have to do nearly as much multiplying with Pascal's triangle. So let's talk about how we do Pascal's triangle. So first of all, I'm going to look at the exponent to determine what row of Pascal's triangle I am going to go out to. Okay, so this is 4, which means we're going to go out to row 4 of Pascal's triangle. Now, when we do this, you can kind of derive it on your own. You don't need to memorize it. So, our row 0, I'll denote that as R0, is just the 1. All right, now row 1, this is our 1 and our 1. Guys, row 0 and row 1 are the only rows you really have to memorize. Once we get past these, you can kind of derive it. So, row 2. Now, something with Pascal's triangle. You always start with a 1 and end with a 1. So I'm going to start with a 1, and then to get the middle term, I'm going to combine these two. So 1 plus 1, I'm going to add them. 1 plus 1 will give me a 2. And then I'm going to end with a 1. So each time we build a new row, we have one more number in the row, and we always start and always end with a 1. So I need to go out to row 4, because this exponent is a 4. So we got rows 0, row 1, row 2. Row 3, we start with the 1 and we end with the 1. Okay, we're going to have two numbers in between. I get the first one by adding these two together. So 1 plus 2 will give me a 3. And then to get my next number, I add these two together. So 2 plus 1 gives me a 3. Alright guys, we're almost there. Let's go on to row 4. Row 4. Okay, I start with the 1. I'm going to have 3 terms in the middle this time, and I'm going to end with a 1. Okay, so 1 plus 3, I'm going to add these, will give me a 4. This next one, I'm going to add these two together, so 3 plus 3 gives me a 6. And to get this final one, I'm going to add these two together. So 3 plus 1 gives me a 4. Now, Pascal's triangle, this triangle is important because this tells me what the coefficients of all my terms are going to be. Okay, so I'm going to have a 1, a 4, a 6, a 4, and a 1 as my coefficients. So let's see what's going to happen. Okay, so guys, I'm going to start by writing these as my coefficients. Okay, which I need to make sure I have enough room to do this. I'm going to write it down here to make sure I have enough room. So I'm going to write 1, then 4, then 6, then 4, then 1. So I'm going to start by writing my coefficients, which came out of row 4. I just wrote these numbers down. That's all I've done so far. Now the next thing we do, we start with the first term in our binomial, which is this 2x, and we start by raising the 2x to the 4th power. So I'm going to write 2x to the 4th, and I'm going to write 2x in all these, but each time I'm going to go down by one exponent, and I should end with an exponent of 0. So my next one will be 2x to the 3rd, then 2x to the squared, or 2x squared, then 2x to the 1st, and then my final one will be 2x to the 0. Okay, so you start by writing the first term in every single term, and you start with this exponent and go down by 1 each time all the way to 0. The second thing we do, we move on to the next term, which is a y, except this time, you guys, it's the reverse. I'm going to make sure a y is in all my terms, but this time, we're going to start at 0 and work our way up to this exponent right here. Okay, so we're going to write 0, and then plus to the 1st power, plus to the 2nd power, plus to the 3rd, and then plus to the 4th. So basically, this term, you start at 4 and go down by 1 each time till you get to 0. And the y, you start with 0 and go up by 1 each time till you get to that number. So they're kind of reversed. After this, you guys, you just combine all the terms together, raise everything to the power, and then you're done. Okay, now, something we have to talk about. This rule is going to come up all the time, so let's talk about it. Alright guys, so if you have two numbers that are multiplied together and raised to an exponent, the way we solve this is by raising each term to that exponent. So 8 times b to the c power is a to the c times b to the c. Now, you can only use this rule if there's multiplication in between these two. If there's addition or subtraction, you cannot do this. A plus b to the c does not equal a to the c plus b to the c. Don't even try that. But if there's multiplication, you just raise each term to the exponent. Okay? So, I'm going to bring all this stuff down. So, I'm bringing my 1 down. Alright, so now we have to deal with this 2x to the 4th. So what this means, I raise each of these numbers to the 4th power, just like I did here. Okay, so this is like 2 to the 4th times x to the 4th. Okay, so if you have more than one number multiplied, raised to an exponent, raise both of those terms, or both of those numbers, I guess, to that exponent. Alright guys, and y to the 0, if you remember, anything to the 0 power is just 1. So that's like times 1. Okay, so before I move on, let's just go ahead and simplify this first term. Let's just do one term at a time. Okay, so I have 1, and then I have 2 to the 4th. Well, 2 to the 4th, let's think about that. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so this is like 16 times 1, which is just 16. Okay, so this is like 16 x to the 4th, and then we have this 1 left over. Well, 1 times anything is itself. So all that reduces down to 16x to the 4th. Okay, guys, so again, this was secretly a 16 right here, 2 to the 4th. 1 times 16 is 16, times 1 is just 16, and all I'm left with is x to the 4th. Okay, so all that reduces down to 16x to the 4th. So our first term is done so. Alright, moving on to our next term. So plus, alright, I'm going to bring down my 4. And then remember, you guys, if you have more than one thing raised to an exponent, you raise each of those numbers to that exponent. So this is going to be like 2 to the 3rd times x to the 3rd. I raised the 2 and the x to the 3rd. And then finally, you guys, y to the 1st. Anything to the 1st power is itself, so just y. Alright, let's simplify this down. Okay, so we're going to bring this down. Let's just simplify the whole term. Okay, 2 to the 3rd. Let's think about it. 2 times 2 is 4, times 2 is 8. So this right here, you guys, is secretly an 8. So we have 4 times 8, which gives us a positive 32, so plus 32. And then x to the 3rd and y, well, I have nothing to combine them to. So it's just x to the 3rd y. And that term is donezo. Yay! Alright, so we just have 3 more terms to do. We got this. Okay. So we now have plus. I got my 6. Alright, 2x to the 2nd means I'm going to raise each of those to the 2nd power, so the 2 and the x, so it'll be 2 squared, x squared. And then y squared is just y squared, so I'm going to bring down y squared. Alright, let's see what magical things happen when we multiply all this together. Alright, so 2 to the 2nd power, let's see, 2 times 2 is secretly a 4, so that's like a 4. 6 times 4 is 24, and it's a positive 24. And then I'm left with my x squared, y squared, which I can't combine those together, so it's just x squared, y squared. And yay, that term's done so, you guys. Alright, next one, let's see what happens. I'm going to bring down my 4. So bring down the 4. So we got plus 4. Alright, this time it's 2x to the 1st, so I'm going to raise each to the 1st power. So it'll be 2 to the 1st, x to the 1st, and then y to the 3rd. Alright guys, well 2 to the 1st is just 2, so that's secretly just a 2. So 4 times 2 will give me an 8, and then all I'm left with is my x and my y to the 3rd. So this will be a positive 8, so it'll be plus 8, and it'll be x, y to the 3rd. And that's it on that one. Alright, this last one's actually not going to be too bad. So we have plus. So let's simplify this one down. Plus. Okay. So now I'm going to bring down my 1. Let's think here, you guys. This is raised to the 0 power. Well, guess what, you guys? Anything to the 0 power is 1. So 2x to the 0 power is just 1. Alright, then I'm going to bring down my y to the 4th. So 1 times 1 is 1, and 1 times y to the 4th is y to the 4th. So my last term, you guys, is just y to the 4th. And that would be my final answer. Oh, sorry guys, same color. Jeez, Miss Long. Alright, so if you see, although we did have to do work in each term, we're doing a lot less multiplying. And ultimately, once you guys get the hang of this, this takes a lot less time than sitting here and doing 2x plus y times 2x plus y times 2x plus y times 2x plus y. Okay, you can. It's not wrong to sit here and do, 2x plus y times 2x plus y times 2x plus y times 2x plus y. If you want to do that, if you're sitting here like, I don't like Pascal's triangles and it hurts my feelings, well, guess what? You can do that. But I'm telling you right now, once you get the hang of this, this will save you a lot of time. Okay, but this is, again, something you don't have to do. It's kind of optional. So, I'll leave it up to you. Alright, guys, so this will be my final answer. Yay! And it's already simplified. When you do Pascal's triangle, you do not have to do any combining like terms. It's just done when it's done. So that's it, you guys. Awesome. Now, example 5 is very similar to this one. So if you want to try example 5 on your own, go ahead and fast forward to the end of the video. Okay. So, first of all, when we do our Pascal's triangle, we got to build the triangle. So let's build our triangle. Okay, we start with 1, which is row 0. Then we have our 1 and our 1, which is row 1. Okay, row 2, we start with the 1, we end with the 1, and this one we get by adding these two. So 1 plus 1 gives me 2. Alright, row 3, we start with the 1, we end with the 1, and to get these two terms, we add both of these together. 1 plus 2 gives me 3, and 2 plus 1 gives me 3. Alright, and we do Pascal's triangle all the way down till we get to this number, row 5. This tells us the row to go down to. Okay, so I got 2 more rows to do. Row 4, I start with the 1, I end with the 1, and I'm going to have 3 terms in the middle, which I get by adding these two together. 1 plus 3 is 4. I'm going to add these two together. 3 plus 3 is 6. And I'm going to add these two together. 3 plus 1 is 4. Okay, and finally, you guys, I have to go all the way up to row 5 because my exponent is a 5. So, row 5. I start with the 1, I end with the 1. I'm going to have 1, 2, 3, and 4 things in the middle. Holy hot dogs. So, I'm going to add these two together. 1 plus 4 is 5. I'm going to add these two together. 4 plus 6 is 10. I'm going to add these together. 6 plus 4 is 10. And holy hot dog, I'm going to add these two together. 4 plus 1 is 5. Okay, so when I do this, I'm going to be referencing this row. These are going to be the coefficients of my, or not necessarily of my answer, but when we start multiplying stuff out, these are going to be the coefficients I'm going to start with. Okay. So when we start Pascal's triangle, I'm going to start by writing out my coefficients. That's my first step. So I'm going to have a 1, a 5, a 10, a 10, a 5, and a 1. Okay, the next step. You start with the first term. My first term is an x. Okay, and I'm going to make sure every term has an x in it. That's the next step. Alright, now, what we're going to do, our first x starts with this number, goes down by 1 each time, and I should end with a 0 if I did this right. So I'm going to go 5, 4, 3, 2, 1, and 0. Nice. Okay, now we do the opposite with the second term. Now, when we have subtraction, this is a little different, you guys. So, we are going to include this whole thing in the second term. Our second term, we're going to be doing a negative 2y each time. So I'm going to put negative 2y in each term. So negative 2y, negative 2y, negative 2y, negative 2y, negative 2y, and one more negative 2y. Holy hot dog, you guys. Okay, for now, I'm going to put Or actually, before we do that, so with your second term, the first term you start at 5, you start at this exponent, and you go down 1 by each time, ending at 0. The second term you start at 0, and you go up 1 by each time, and you should end at that exponent. So this will be to the 0 power, to the first power, to the second, to the third, to the fourth, and to the fifth. Alright guys, and the last thing we do, we're going to separate all these with plus signs. Now they might not end with the plus sign, but for now we're going to start with plus signs. And I put those in between all the coefficients. So in between all these numbers, I'm going to put my plus sign. Okay, let's get going. So we're going to simplify down each term like we did up here. So let's get going. Alright, so we have our 1. X to the 5th is just x to the 5th. And then I have this negative 2y to the 0. Well, remember you guys, anything to the 0 power is just 1. So all that reduces down to is just a 1. Alright, let's start multiplying. 1 times x to the 5th is x to the 5th, and x to the 5th times 1 is x to the 5th. So all this is, you guys, is x to the 5th. So this went to that, and this just goes down to x to the 5th. Holy hot dog. So our first term is done. Alright guys, we got this. We got 5 more to do. Okay, so let's bring down this one. Alright, I'm going to bring down my 5 first. So plus 5. My x to the 4th is going to stay as x to the 4th. And then I'm going to raise both of these numbers to the first power. So I'm going to raise my negative 2 to the first and my y to the first. Alright, which negative 2 to the first power is just negative 2. So this is negative 2. Alright, so let's start combining. 5 times x to the 4th is 5x to the 4th. Times negative 2 is negative 10x to the 4th times y is y. Or if you just want to multiply the numbers first, then the variables, I think that's personally the easiest way to do it. So 5 times negative 2 is negative 10. So now, since I got a negative 10, it will be minus 10. Alright, now let's combine our variables. X to the 4th, y. They are not like terms, they're not like variables, so I can't combine them. So it'll be x to the 4th y. And that term is donezo. Bam. Alright, let's move on to our next term. Bring down my plus sign, and then the 10. I got my x to the 3rd. X to the 3rd is just x to the 3rd. And now I'm going to raise my negative 2 to the 2nd power and my y to the 2nd power. So each of those to the 2nd power. So I have negative 2 to the 2nd and y to the 2nd. Okay, which negative 2 to the 2nd, let's think. Negative 2 times negative 2 is positive 4. So that's just a positive 4. Alright, let's reduce this down. 10 times 4 is positive 40. Alright, and then x to the 3rd times y squared, well, I can't combine those, so it's just x to the 3rd y squared. Bam, that one is donezo. Okay, let's keep going, you guys. I got another 10 to bring down. Bringing down my 10. Bring it on down. Got my x squared, which just remains as x squared. Alright, now I'm going to raise both of those bad boys in there to a 3rd. So the negative 2 to the 3rd and y to the 3rd. Alright, let's see what negative 2 to the 3rd is. So negative 2 times negative 2 is positive 4. And positive 4 times negative 2 is negative 8. So this is secretly negative 8 right here, you guys. So be careful. Okay, so 10 times negative 8 is negative 80. And then x squared y to the 3rd, well, guess what? I can't combine them. So it's just x squared y to the 3rd. Alright, and that one's done. Alright, so we just got 2 more terms. Then we're done. Okay, so now I'm going to bring this one down. I'm going to bring down my 5. X to the 1st is just x, so I'm going to write it as x. Alright, and then this next one, negative 2y to the 4th. It's negative 2 to the 4th y to the 4th. Okay, so let's see what negative 2 to the 4th is. So negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. And negative 8 times negative 2 is positive 16. So this is positive 16. Okay, let's bring this down. So 5 times 6 16 will be 80. I'll double check, but I'm pretty sure that's right. 16 times 5, yes, 80. And that's a positive 80. So positive 80. And then my x and my y to the fourth remain as x, y to the fourth. All right, and finally, you guys, we just have one more. See, this isn't so bad. Okay, let's bring down our next term. We got our 1. Our x to the 0. Anything to the 0 power is just 1. So this is 1. All right, and now I'm going to raise both of these to the 5th power. So negative 2 to the 5th and y to the 5th. All right, guys, let's see what happens. Negative 2 to the 5th. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. And positive 16 times negative 2 is negative 32. Holy hot dog, so this is negative 32. Alright, guys, we just got to combine these, then we're done. 1 times negative 32 is negative 32. And then I just have a y to the 5th because 1 times 1 is 1 and 1 times negative 32 is negative 32. So I just left with y to the 5th. And that would be our final answer, you guys. So all of this process does take some time. Okay, there's a lot less things you have to multiply. So first of all, you will make less mistakes using Pascal's triangle. I'm going to tell you right now, you're going to make less mistakes. Okay, and again, I'm telling you, once you get the hang of this process, this is much faster than taking this and multiplying it out 5 times. So secretly, this is x minus 2y times x minus 2y times x minus 2y times x minus 2y times x minus 2y. Okay, you can. If you're like, I cannot stand Pascal's triangle, it makes my life miserable. Well, guess what? You can multiply all that out. But I'm telling you right now, it's going to take a lot longer and you have more chances to make mistakes. But it is not wrong, and if you want to do it that way, that is fine. Now, something else I wanted to point out, you guys. So, again, with Pascal's triangle, this is always your final answer. You don't have to simplify or combine any like terms. But something I want to point out, which you probably noticed. Do you guys see how my signs are alternating? I go positive, negative, positive, negative, positive, negative. That will happen every single time you have a minus sign in Pascal's triangle. Okay, if you notice up here in this one, we had a plus sign and all the signs are positive. That will happen every single time. Okay, so positive in the middle, all your answers should be positive. If you have a negative sign in the middle, your answers should alternate between positives and negatives. Alright guys, so that is it with Pascal's triangle. I hope that you love Pascal's triangles as much as I do. And also, by the way, the little gecko thing in Tangled was totally named after Pascal's triangle, so you should appreciate it. Alright guys, have a good afternoon, morning, or evening.